Okay. Hello, good evening, everyone. Thank you for having me here. I want to talk today about Kubernetes network observability, specifically with Cilium and Hubble. To start with, just a few words about myself. I work for Isovalent, which is now part of Cisco. I'm based in Wrocław, Poland, so not too far from here. Came especially for this meetup to meet and discuss those topics with all of you. My role with Isovalent, it's customer reliability engineer. So I work directly with the customers using Isovalent enterprise products, and I help them to meet their reliability requirements. So how to make sure their network in their Kubernetes cluster or clusters is really reliable. So this means supporting the products of Isovalent like Cilium, Hubble, Tetragon, where Cilium provides networking, Hubble provides observability, and Tetragon provides security and security observability as well. And all of those, they are based on eBPF, so the underlying technology in the kernel that also we at Isovalent developed. So that's just a little bit of context about where I'm coming from and the plan for today. I will start with a very short refresher of what's Kubernetes networking, then a few words about CNI, what this concept is, then an intro to Cilium and Hubble, and then the last part, we will do a live demo. I will try to show you how it all works, how to get observability into the networking in Kubernetes clusters. To start with, I want to check with you. So who of you is using Kubernetes in production? Okay, pretty much almost everyone. Who knows how Kubernetes networking works? Please write. Okay. Who knows all the details about all the very details how it works? Please raise your hand. Yeah, me neither. I'm supporting those things for 1.5 years, and I'm still discovering new things every day. So, yeah, basically those things aren't easy, I would say. But let's do a refresher of like the very basics. So, to me, when I think about Kubernetes networking, there are some very basic concepts, very basic requirements, what the Kubernetes standard requires from the networking perspective. So every pod in a Kubernetes cluster should get an IP address, and there should be connectivity between those pods. So the pods can be running on different nodes, and there should be connectivity provided between them. There are two kinds of connectivity. There is what we call east-west. So on this picture, you can think left to right, one pod connecting to the other. That's typically done by services, service type cluster IP. It's what you typically use to connect from one pod to the other. Typical implementation is with kubeproxy. You typically also need service discovery. So in your cluster, there would be an internal DNS server, typically implemented with core DNS, which lets one pod to discover those services, how to reach the other pods. And then north-south connectivity. So when you are coming from outside the cluster up there, you need to reach your workloads somehow. Typical implementation for that is also a service, but with a type of the service load balancer, which means you will get an external IP by which you can reach to the service and then to the workloads, to the pods in your cluster. Plus, yet another aspect of networking in Kubernetes is security. So once you made sure all those things can talk to each other, then the time comes when you want to limit it to some degree. So you want to have isolation or microsegmentation, which means you want defined rules. Which pod can talk to which one? Traffic coming from the outside of the cluster, which pods can it reach? This is implemented with network policies. And you might also want to encrypt the traffic on the wire. So on the bottom side of the diagram here, you have the physical network, let's say, between the hosts. So you might want to encrypt the traffic going through that physical network. So those are, to me, the most important security aspects. So that would, in my mind, cover the very basics of what we want from Kubernetes networking. Of course, there is much more, but don't want to dive much more there. Then, let's do an intro to the CNI, what that concept is. So, container network interface. The very basic idea is that Kubernetes as a project, it doesn't prescribe a specific implementation of how this cluster network should be implemented. It allows for different projects to implement the network in different ways. What is the problem space to cover here? So first is the dynamic network configuration, and which means in Kubernetes we have our workloads, our pods, which have a really dynamic nature. Your workload can run on whatever of the nodes, and you need to get the networking configured for those pods and containers in those pods. So CNI it implements how those network interfaces in the pods are configured. It's responsible for assigning the IP addresses to the pods. Also, to implement connectivity across the different hosts in the cluster. So you get this virtual network. As you can see on the bottom part, you have the IP addresses for the hosts in the cluster, but then the pods, they get IP addresses from a different network, from this virtual network built on top of the physical one. And it's the role of CNI to basically implement this connectivity between pods. The specific implementation, this can be done in different way. So to get those workloads interconnected, you need to configure routing between them. And two typical implementations are either encapsulation, so what's called an overlay network. One of the technologies possible there is VXLAN. So your CNI can configure this overlay network for you, and then can configure the routing based on that. The other option is native routing, which means you don't use tunneling protocols, you don't do overlay, but you rather allow routing directly in between the pods. All this is implemented by CNI plugins. So Cilium is just one of them. There are many other options available as well. But today, I will talk about Cilium, so what we've built. Okay, now only a very short intro to Cilium and Hubble, so that, yeah, to cover the basics of how Cilium works, and then we will jump into the observability. So very basic level again. We have a cluster with 2 nodes, a bunch of pods there. So CNI is what implements connectivity. There is kubeproxy used for networking as well. So kubeproxy is the component that implements specifically the services for both east-west and north-south connectivity within your cluster. The standard implementation is kubeproxy, uses IP tables to implement those services. And then you can see those nodes, they have their physical interfaces, so Ethernet 0 here, but there is also the VXLAN tunnel configured in between the nodes so that those workloads can talk to each other. Cilium's implementation, it's like architecture almost the same with one significant difference. So we have Cilium as the CNI, but then instead of using kubeproxy, we implemented most of the features using eBPF, which means you typically will not have IP tables used to implement the services and some other features of Kubernetes networking, but rather it's done with eBPF programs within Linux kernel. Zooming in just a little bit, I will try not to go too far into details, but again, how this architecture looks like on one of the nodes. So the most important component here, or 2 important components, would be the Cilium agent. So it runs as a pod on each of the nodes. What it does is, as you can see, two most important things here. So it talks to Kube API server to get the objects that are relevant for networking. So what are all the nodes, the pods, what are the network policies, also all the services and endpoints within those services. Based on all this information, it then implements the networking configuration within the Linux kernel using eBPF. So it installs a bunch of eBPF programs in the kernel that then make sure that you have really efficient and performant networking done as near to the networking hardware and as near to the processes running within the pods in your cluster as possible. So you are basically able to cut down all the overhead there. A little bit more of the architecture. I don't want to describe this in all the details because it already gets somewhat complicated, but to me the important bits here are we have within the cluster this extra component called Cilium operator, which is used to talk, for example, to your cloud providers to get all the information about the networking details and all the nodes and all the cloud objects from there. There is kubelet there as well, so kubelet uses Cilium CNI, a binary on the node, which then calls Cilium agent to then implement the network for a pod on a node. Plus, there is Hubble as well. So the main part of Hubble is implemented actually within the Cilium agent, and then this specific implementation of how observability works is done actually with those eBPF programs in Linux kernel. So the role of Hubble is to provide observability for your Kubernetes networking. So you can think about it, the Cilium itself is responsible for providing connectivity, and then Hubble, you can think about it as a sub-component of Cilium that brings you observability on top of it as well. And one more thing showed here, with Hubble you can also export different kinds of observability data. So you can get visibility into networking flows, you can get metrics for what's going on in your Kubernetes network. You can also get traces. So all of this can be exported from Hubble. Okay, so that was pretty much it for the theoretical part. And now I will try to do a demo. That's my very first time doing this demo, so yeah, please bear with me. We'll see how it goes. Maybe before we start, are there any questions to the part I covered so far? Okay. Yeah? Sorry. Yeah.
I'm just wondering that since you are using eBPF instead of IP tables, or that's what you basically said, does it mean that you can suddenly use IMCP to ping your services?
Sorry? ICMP to ping services?
Because right now you cannot ping your services in Kubernetes because it's all implemented using IP tables. So I was just wondering if that's suddenly possible using Cilium's eBPF.
No, as far as I'm aware, it's like still implemented as like either TCP or UDP rules. So that would be what I expect. Okay, let's jump into the demo. Is the font size large enough? Good? Okay. So first one will be, I will try to show you how can we get insight into the networking flows in Kubernetes. I'm using I based on one of our labs that we published at Isovalent. And yeah, based on that, I've built a demo, adjusted it for what we need today. We have a very simple kind cluster with just 3 nodes there, with Cilium already installed. So when we run Cilium status, we can see all the components are up and running. There's Cilium operator, then Envoy proxy, and Hubble relay. Let's take a look into Cilium's configuration. So what we have here, it's a bit different from the most basic or default Cilium configuration. we've adjusted a few things to enable observability. The most important bits that we can see here is that we enabled Hubble relay, as you can see here. Then we enabled Prometheus metrics for both Hubble relay and Cilium itself. And then we've configured what metrics should be exported from Hubble within the Cilium agent. Specifically, there is this list of metrics configured. We will take a look into those a little bit later, because that's what's important for what we want to see today. Okay, that's pretty much what's the most important here. And let's then take a look into what we have running here in this cluster. So we have a demo application. It's like an architecture consisting of a number of workloads. So there is a bunch of deployments and a daemon set, all of those interconnected with one another. We can also see the services. So there is also a bunch of services. So all this are basically a number of pods in this tenant jobs namespace. Yeah, all talking to one to another. And then the question here is like, how can we get observability to see what's going on the network there? So the first approach from the old days of traditional networking would be, let's just use TCP dump. Let's see what's happening on the wire there. So I'm executing into one of the nodes, then I'm running TCP dump, dumping the traffic from ETH0, and then I'm interested in port 8472, which is the VXLAN tunnel in between the nodes. When we run this, we can see how the networking traffic looks like on the wire. The most interesting bit to me here is that for each packet, we can see such many lines. And specifically, the interesting bit is that we have 2 layers of IP addresses here. So first, I have the UDP frame here, which is the outer headers of the VXLAN tunnel. Those are the node IP addresses, and then inside there are the pods IP addresses, and we can see the inner packet here. Specifically, here this is a TCP frame going between the pods within the VXLAN tunnel. We can also try using Wireshark for this traffic, but it wouldn't be super useful as well. So if you try to look into those packets with Wireshark, you will see a similar picture. So there are the outer headers for IP and UDP. So you have your node IP addresses. You have the UDP port 8472 for VXLAN. Then you have VXLAN headers. then pod IP addresses, and then here the TCP frame for the traffic between the pods. What are the problems with this approach? Yeah, any ideas? Yeah. Yeah. Fragmentation wouldn't be a problem because MTU is typically set properly for the pods, but there is some overhead indeed for the encapsulation, for the overlay. I meant maybe more from the observability perspective. In my mind, the main problem here is that those IP addresses that we see with traditional network observability tools, they aren't super useful in the Kubernetes world. Because how can I then translate which pod talks to which one? Specifically, if my workloads are dynamic, those pods are coming and going, it's not a static network, but it's all changing all the time. So even if I export all this data somewhere, I don't have an easy way to map which workloads are we seeing here. So that's exactly the problem that Hubble tries to solve. And let's take a look how it's done. So what we can do with Hubble is, let's maybe see one more thing first. So in the kube system namespace, we have this service called Hubble Relay. We also have the Hubble Relay deployment. So the role of this one is to allow you to query all the Cilium agents in the cluster for all the networking flows, networking information going in between the nodes. So what's going on each of the nodes, you can use Hubble Relay to query all of them at once. And from the end user perspective, that can be done in a few different ways. One of which is the Hubble Observe CLI. So we have one basic command here. We want to observe networking traffic within this cluster within the specific namespace. So we are already talking about Kubernetes identities, Kubernetes concepts here. So only traffic in this tenant jobs namespace and only traffic that was forwarded. Because Hubble, it lets you observe many different kinds of events in the network. But for now, we just want to see what was forwarded. What we can see here. So there is the source workload, so a specific pod called resumes in the tenant jobs namespace. It talked to another pod, core API. We can see the port numbers as well. We can even see the TCP flags on those flows. So it was like first SYN, then SYN-ACK, and then the connection was closed at the end. It allows you to also filter, to use different filters quite similarly to TCP dump, but I would say on a higher level, because you can query by Kubernetes concepts. So for example, I again want to look into the tenant jobs namespace, the forwarded flows, but only for the pods with this specific label. So only traffic for the core for the pods with the app equals core API. And now we got the results filtered by this specific pod. We can similarly do stuff like we can say only from this label, and then it goes like from core API to resumes. Okay, so that was network flow visibility on layer 3 of the OSI networking model, but we can also get visibility on layer 7. So to get application layer visibility, what's going on the network on the higher layer. To do that, we need to use Cilium networking policies to enable this layer 7 visibility. Who of you here is familiar with Cilium network policies? Okay. With Kubernetes network policies? Okay, a little bit more. Okay, I will try to describe what I'm doing here. We will have about 3 different network policies that we need to configure here. So, as I said in the intro, the network policy concept, it's mostly meant to configure those rules which would say which workload can talk to which one, which pod can talk to each other pod. There is the Cilium network policy kind of Kubernetes object to configure that. In this case, we are configuring a network policy that will allow all the traffic within the given namespace. So it allows all the traffic within this tenant jobs namespace. And it says allow egress, so outgoing traffic, to all the endpoints within the namespace. And then similarly, allow all ingress traffic from all the endpoints within this cluster, actually. And then this policy is applied to all the endpoints within the tenant jobs namespace. So the first one, it just allows all the traffic, and then we will have another 2 policies to enable the layer 7 observability. So I'm applying the first one. Then we have DNS visibility policy, which is already a network policy working on layer 7. What it does, it's still applied in the tenant jobs namespace. It applies to all the endpoints within that namespace. It configures egress rules, which are like applied to all the allow traffic to all the entities in the cluster. And then to all the endpoints that are matching those labels. So basically traffic to kubedns, traffic going to port 53. We configure a layer 7 rule, which say we want Cilium to match all the DNS queries. So what this rule does, it tells Cilium that all the traffic within this namespace going to kubedns to port 53 should be then redirected to what we call DNS proxy which is part of the Cilium agent. And then this DNS proxy will decide if this specific DNS query should be allowed or denied. Here we said we are allowing all the queries. But additional thing coming out of it is that we will now have observability enabled for all the flows that are going through that DNS proxy. And observability on layer 7. So we will be able to see what's going on the application layer. So let's apply this network policy, DNS visibility. So we have now two different network policies. First, to allow all the traffic, and second one, DNS visibility. And now we can use Hubble observe again. So again, in the tenant jobs namespace. But I'm now saying, please show me all the flows with protocol DNS. What we can see now is traffic to core DNS to port 53. We can see those DNS requests going through the proxy, Cilium DNS proxy. This traffic was forwarded. And here we have the layer 7 information. So we can see what were the specific queries. And also we can see what were the answers. So for example, here, for this specific query, so an application was asking for this FQDN, and the answer was this IP address. So by using the layer 7 network policy, we redirected the DNS traffic through the DNS proxy within Cilium agent, and this enabled us to get layer 7 visibility with Hubble observe. We will do the same for HTTP traffic. So we have yet another Cilium network policy, again, layer 7 policy. It's applied to all the endpoints within the tenant jobs namespace. And then it configures an ingress rule, which says traffic to those specific ports. Those are the ports that different applications in this namespace are listening on. This traffic will be allowed, and there is a layer 7 rule, which says for HTTP traffic, all kinds of HTTP requests should be allowed. So again, we are not denying any kind of traffic here, but by applying this rule, we instruct Cilium that all HTTP traffic going to those specific ports in this namespace, it should go through a proxy again. This time, the layer 7 proxy for HTTP, it's Envoy proxy. So this traffic will go through Envoy proxy, which allows either to configure those layer 7 rules, but also it allows us to get visibility into layer 7 protocols. So I will apply this policy, and then we'll use Hubble observe again with protocol HTTP. And what we can see now is that we added yet another thing to our network observability here. So we are able to see the traffic going to those specific ports that our HTTP services listen on. We can see it's an HTTP request, and then we can see more layer 7 details, like it was a post request, to this specific workload, this specific endpoint. We can also see the responses here. Like this was, for example, 201 response. We can get even a more detailed view into this. So this is the simple view, let's say. But then if you are interested in more details, you can get the whole object as exposed from Hubble, and then see a lot more detail about our traffic. So, for example, here we have an HTTP request, which was a POST request to this specific endpoint. But you can get details like all the headers of this request, then the details about the Kubernetes level information about the source and destination. So the destination here was tenant jobs namespace, a pod with this name and those labels, and also your traditional layer 3 and layer 4 information. So what were the IP addresses, what are the ports used. So those are all the details visible through Hubble. If we scroll up a little bit, we have an HTTP response here. So we can also see things like response code here or response latency. So how much time it took for the destination to respond. Okay, that's pretty much it for what we can do with Hubble Observe. But then we have two other ways to look into this traffic. So the next one is our Hubble UI. Within Hubble UI, we have a service, Hubble service map implemented. Let me refresh it. So what it does here, that's, let's say, a simple UI built on top of all those data that we were looking at with CLI. So the underlying data, it's exactly the same what we looked at just a moment ago. And what we do with it is first, we are able to see all those flows flowing through the cluster real time here. We can look into them in more detail. So all those things that we were seeing in the CLI. But then based on those data, we are also drawing a map of all the workloads within this given namespace. So you can see there are workloads like Core API. For example, it talks to Elasticsearch on a specific pod, and it sends HTTP traffic there. Or, for example, some pods like Core API and Entity Operator, they are talking to Kafka on two different pods, two different ports. So you can get just an overview of your network topology. You would also get information here about what traffic is forwarded, what is dropped. Right now, we have those policies that allow all the traffic, so we can see all the things forwarded here. Okay, so that's the Hubble UI. And then the last part that I want to show is the metrics that are exposed from Hubble. So if we check the Cilium Helm values again, we had this section of what metrics are exposed from Hubble, which is part of Cilium. We will be specifically interested in the flows and HTTP metrics. It's like quite a lot of configuration here, so let me jump here. This is all documented in very detail here, but looking just at those two that we are interested in. So we have the flow information exposed, which expose flows processed total metric, which is a total number of flows. But then within this metric, we can configure different type of context labels to have all the context about those flows exposed in the metric. So, for example, here we want to see what is the workload name, but if we don't have a workload name, we want to see reserved identity. So, for example, workload name can be the name of a pod within my cluster, but if that's traffic going to outside of the cluster, we would see identity, for example, world going to the outside world. And the other one is HTTP. And here we will have two metrics: requests total, which is the count of HTTP requests. And the other one is histogram of the request duration. So you can see in detail how much time requests were taking. And similarly, you have all the labels here. So context like what is the source, IP namespace, workload, similarly for destination, to be able to see this in detail in your metrics. So let's take a quick look into this. We will check those metrics using the Hubble metrics service. This is a headless service, so without a service, a cluster IP. But then there are 3 different endpoints behind it. So it basically directs the queries to that service to all Cilium agents within the cluster. So let's query the service. I will go through one of the pods, and then I'm querying the metrics there, and I'm interested in HTTP requests. I might need to run it a few times, because each time it can reach another instance of Cilium. But what we can see here is we have requests going to Elasticsearch master. We can see destination IP, what is the namespace, what is the workload, the method, and also things like all the information about the source, but also stuff like status codes. And then obviously the number of such requests. Similarly, we can do the same and check a specific workload. So for core API, we have a bunch of different requests, types going there, and the metrics for all of them. So now let's jump into Grafana to see how we can visualize all of that. So we have this layer 7 HTTP metrics dashboard here. What we can see here, what is the volume of requests? Then we can dive in to see those divided by the response code. So we can see here for resumes, we've got mostly HTTP 200 responses, but some requests are also getting 500 or 503. And we also get stuff like success rate here and also request duration. So we can see that our 50th percentile for the request duration is around 30 milliseconds, but the slowest requests are around 250. To show you how it changes, we can implement a small change. So I will instruct my core API service to increase the latency for some of the requests. Okay, so I have my core API restarted. If we take a look here on those requests, we can see some of those have a longer duration. So latency varies. And then if we jump back into Grafana, in a few moments, we should see the duration increasing here as well. Okay, so as we can see, the number of requests went down here, and the especially 99th percentile of the request duration, it goes up because our core API service started to be more slow to respond. Yeah, this is pretty much what I have for this demo for network flows observability. Yeah, you can play with those things yourself as well. So we have all labs like this one, like what I was showing, available at isovalent.com. Especially, I would recommend those. So we were playing with the golden signals today for HTTP, but the other interesting stuff are like Hubble flow visibility, the network policies lab, or zero trust visibility, another lab that shows how you can use Grafana to visualize your network traffic and also your network policies. Yeah, that's it. Do you have any questions then?
Yeah, we have a few on a Slido.
Okay.
So I can read that to you. It's okay? Oh, okay. You can read it on your own. So I'll highlight the first one.
Supporting Hubble, is it the primary use case of Cilium? Not really the primary one, because like what you typically use Cilium for is basically for like two main reasons why people implement Cilium are typically to allow robust network connectivity within the cluster. So to allow connectivity between all your pods, all your workloads, to do it in a very efficient way as we use eBPF and we implement all this networking in the Linux kernel. And then the second most popular use case is network policies. So you want to add extra security to configure what workloads can talk to what other workloads. And then the third use case that I can see with the end users is observability indeed. So yeah, like Hubble is within the main use cases, but I would say it comes third there. What's the next one? Can I use Hubble without full install for some ad hoc layer 3 debugging? Not really. I mean, if you use Cilium as the CNI, you already have Hubble included. Sorry? Yeah. By default, it's without relay. Adding Hubble relay, it's not a major change. Like you just need to enable Hubble relay in your Cilium configuration. By default, you also don't have all those metrics exposed, but that's again quite a small change. So yeah, ad hoc is not an option, but I would say if you use Cilium, it's not a big overhead to enable Hubble relay there. What's the next one? Does each L7 protocol need protocol decoder in Hubble? Yep. So to be able to get layer 7 observability, you need to decode those layer 7 protocols. How it works currently in Cilium, we don't implement this in eBPF in kernel, but we use the user space proxies for this. Our, I think, 3 main use cases are DNS, HTTP, and Kafka. So we have decoders for those. And yeah, basically you need to go through a proxy to decode those protocols. The next one. Is there overhead of redirecting traffic to the agent with netpols? Is it safe to leave it after the debug session? So is there overhead? Yes, there is some small overhead indeed, like your traffic doesn't go the shortest path possible through the kernel anymore, but it needs to be redirected through the proxy as well. The redirection itself is done within eBPF, so this traffic doesn't need to traverse all the TCP/IP stack several times. It's still just one traversal, but yeah, but obviously there is some overhead if you need to go through that additional proxy. I don't know the exact numbers by heart, but what we typically see is that this overhead is really, really small, and it's like it's not causing any kind of performance issues for the users. And the other part was, is it safe to leave it after debug session? What we typically see with our end users, our customers, is that they don't change this configuration ad hoc when they need to debug the network. They rather configure it permanently. So they typically decide, okay, we want all our DNS traffic to go through a proxy, to then use both the network policies to allow or deny that traffic and to get observability as well. Does Hubble Observe just show last N results from the background buffer? Yes, it does in the default setup. So by default, Hubble has a circular buffer implemented that keeps just a number of requests or flows that fits into that buffer, and then the newer flows are overwriting the oldest flows. What we also make possible is that you can also export all those Hubble flow data to like the data store of your choice. So it becomes typically just a text JSON file that you can redirect somewhere. Okay. How well does Hubble play with HTTPS traffic within the cluster? Not as verbose as HTTP. That is correct. Typically, HTTPS traffic, we wouldn't have visibility into this traffic because it is encrypted, obviously. We do have a feature of HTTPS intercept, which allows you to basically make those HTTP flows go through the proxy, still terminate HTTPS there, and then to get observability for layer 7 as well. But of course, this comes with another set of risks, constraints. You need to take care of HTTP TLS certificates and all those stuff. Hubble UI. Does it have same filter capabilities as Hubble CLI? I'm not 100% sure here. Like, you can configure different kinds of filters in the UI, but I wouldn't expect it to have the exact feature parity with the CLI. So I think the CLI is way more powerful, and then a subset of those capabilities are available in the UI as well. If enabling observation redirects the traffic through proxy, can it change behavior of observed traffic? Is it recommended to leave the redirection rules? Yeah, to leave the redirection rules, as I said before, typically our users have those rules in place permanently. Does it change behavior? Not really. I guess, for example, with the only thing that comes to my mind is that there is this extra redirection, so there might be like slight latency added on top of your standard traffic, but yeah, to me that's pretty much it. Single point of failure as a cost of HTTP observability. I would say that's typically not what we see, mainly because this envoy proxy that the layer 7 traffic needs to go through, it's implemented as a daemon set on each of the nodes, so that it's still a separate proxy on every node, and it's like your failure domain. To me, it doesn't change so much. Yeah, so I wouldn't say it adds to like risk or like another factor for your reliability. HTTP proxy timeout configurable in envoy proxy. So we have a possibility to configure like specific envoy proxy configuration. There is a CRD for that within Cilium, which is Cilium envoy configs. But this is pretty low-level stuff, and we typically we advise against actually using it. What we typically advise our users and customers to stick to the default configuration of the envoy proxy and not to try like fine-tuning it more. Yeah, that's our typical approach.
So I have last question.
Yep.
So you said that Hubble can help us with the observability. So how can help me with the tracing? Tracing, yeah.
We do have a capability to expose open telemetry traces, although from what I can see among the users, it's that this one is not something really commonly used. So what people typically do with Hubble is the flow observability, as I shown, and then typically the metrics as well. The tracing, it's not among the typical use cases.
Okay, so I think that's it. So if you have any question, so you can ask Tomasz during the networking part. So thank you, Tomasz.
Thank you all so much.
And now we will have 10 minutes break, so you can grab some food and drink, and then there will be second talk. So.